right, welcome again, pre-calculus students. Looks like we're ready to go here and take a look at today's learning, which is going to be ellipses again, but specifically we're going to get a little bit more into their equations and particularly talk about something called eccentricity, which is something we didn't have with parabolas, but we do have with ellipses. And so let's look at let's start with eccentricity and what do we mean by that. So if we think about the word eccentricity, which is a measure of how eccentric it is. Now, eccentric is a word that I would imagine that most of you have heard, certainly our English-speaking students, English as a first language speaking students, those of you that are learning English as a second language, our international students, maybe you haven't heard of eccentricity, but it's a good word to learn, the word eccentric. So if you think about what it means to be eccentric, it's basically the type of word that someone is strange or different or kind of out there. And you can almost think of it as being off-centered, something like that. That's kind of what we mean by eccentric. Well, when we talk about an ellipse, what it is it's a measure of how non-circular it is. So the less circular it is, the farther away it gets from the center, the farther away it gets from what we think of as being normal, then the more eccentric it is. So here's the way we measure it. If we think about the ellipse the way we talked about its features, basically the closer A and B are together, the more centered it is. So you think about the idea of eccentric, it's less centered. So our E, we use E for the measure of eccentricity, and we look at the ratio of C over A. Notice C is the distance from the center to a focus, and A is the distance from a center to a vertex. Well, what happens in a perfect circle, what happens in a perfect circle, when A and B are exactly the same length, C becomes 0. So an eccentricity of 0 would be a perfect circle. So we can think of it like that. And so the eccentricity is going to be between 0 and 1. If it's 0, it's a perfect circle. The closer it gets to 1, the more eccentric it becomes and the more oblong it becomes. So let's look at how we apply that. So let's look at number 21, which gives us the following information. It tells us our major axis has a length of 6 and it's on the y-axis, and our minor axis has a length of 4 and it's on the x-axis. The implication here is that they're both centered at the origin here. So, and it wants us to find out our equation for that. So we know we're going to have it look like this for our basic equation, because since the major axis is on the y-axis, we know it's oriented vertically, so we know that the a squared has to be underneath the y, and the b squared has to be underneath the x. So we know it's going to look like this. Now we can use this. If the major axis is 6, then we know that the semi-major axis, well, first off, since it's centered at the origin, we know h and k are both 0. So we know it's going to look like this, with just y squared if k is 0 and x squared. We know the denominators, if the major axis is length 6, then the semi-major, or half of that, is 3. So when we square it, we get 9. And if we know the minor axis is length 4, the semi-minor is 2. So when we have 2 squared, we get 4 equal to 1. And that becomes our equation. Pretty straightforward, pretty simple. Now it does ask us to identify our center, our A and our A and B, and they're listed right there. Okay, let's look at 31. 31, once again, we're finding our equation. And so we're given the following information. I'm opening up the book to make sure that I say exactly what we are supposed to find here. So it wants us to find the equation, And basically it's just, it's all we have to do here. So the key thing here is our vertices tell us our orientation. We have to know whether it's vertical or horizontal. Notice it is the y coordinate here that is changing. The x stays the same, so it's a vertically oriented ellipse. So I know to grab our equation for vertically oriented ellipses. Then I'm going to go ahead with this, and I have to identify, in order to fill this in, I have to identify my h, my k, my a, and my b. So the first thing I can look at here is let's identify the h and k. So notice the h value, since the x value does not change here, is just going to be 1. That's pretty straightforward. For getting the k, it's halfway between -4 and 8. A few different ways to find that. I can figure out, okay, halfway between -4 and 8, there's a difference there of 12, so I can add 6 to this or subtract 6 from that and get 2. I could also just add up -4 and 8 and divide by 2, get the average of those two. Either way, I get a value of 2 for my k. So now I can go ahead and plug those in for h and for k. And now what I need to do is and I would get this if I do that. Now what I have to do is find my a and my b. Well, notice I have a, if this is my vertex, sorry, this is my center, this is a vertex, going from 2 to 8 goes 6, so a would be equal to 6. And then my minor axis is length 8, so half of that would be 4, so b is 4. So then substituting in, I know a must go underneath the y, so that's going to be 36 and 16, and I've got it. All right, let's look at another one, how we're applying this. So 33, we are still doing the same thing, finding an equation. But now we have foci and vertices. So once again, do the same thing, look for orientation. Notice the value that's changing here in the vertices or in the foci is the x value, so this is horizontal. So I will grab the equation for a horizontally oriented ellipse, which means that the a is going to be under the x. So now I've got to go and I have to find first the center. Doing just like I did before, I can use the foci or I can use the vertices. Here, if you want to, add up 0 plus 6 is 6, divide by 2, 3. Or I could add up 1 and 5 and get 6, divide by 2 and get 3. Either way, we get 3. We have -4 there for our k value. So our hk would be 3, -4. Now we need our a and we need our b. Now, to get the a, since I know this is my center, this is a vertex, so to go from 0 to 3 is 3 away, or 3 to 6 still 3 away. So I know a is 3. Pretty easy to figure out. B, on the other hand, not quite as easy, because I don't have anything about the semi-minor or the minor axis. But I do have the foci, which tells me about C. So I will have to use my Pythagorean relation. So notice that the distance from my center to a focus, going from 3 to 5 here, is 2. Or I could say going from 1 to 3, it's 2 away. So I know that C is 2. So I'm going to use my Pythagorean relation here. A squared is equal to b squared plus c squared. I know a squared, if a is 3, a squared will be 9. If c is 2, c squared will be 4. So I can set that up and I can find that b squared is 5. And I could say that b itself is square root of 5, but in my formula, I need b squared. So I've got it. B squared is 5. And I already know a squared is 9, so I can fill in my equation here. Filling in 3 for h. -4 goes in for k, so that becomes y plus 4. And then I've got 9 for a squared, 5 for b squared, and I have my equation. All right, so far we haven't used eccentricity yet, but we need to do that. So let's go ahead and let's look at 39. 39 is a little different because it gives us the equation, and it wants us to find center, vertices, foci, and eccentricity. So we have a few things that we need to find here. So let's look at how we're going to do that. First, the center is the easiest. Notice in this case here, the x coordinate, the h, is going to be found with the x here. So I know that's going to be 7 because it's x minus h. So my center is the h is going to be 7. And this is going to be y minus k. So this would be -3 for the k. So my center is 7, -3. Now notice in this case, I have to figure out, is it vertical or horizontal? We can't just assume because y comes first it's vertical. We have to look at which one has the biggest number underneath it. And y does have the biggest number underneath it, so it is a vertically oriented ellipse. So I take the square root of the biggest number. That would be 9. So 9 is going to be my a value. So to get to my vertices, I must add and subtract 9. And in this case, since it's vertical, I must add and subtract 9 from this -3. So if I subtract 9 from that, I would get -12. And if I add 9 to the -3, I would get 6. So those are my vertices. Now I need my foci. Now to get my foci, I don't have the c value. I must use my Pythagorean relation. So there's my Pythagorean relation. And I know a squared is 81, b squared is 64, so I can substitute in and solve for c. I know that the c there is square root of 17. So for my foci, I must add and subtract from the -3 the square root of 17. So I know 7 is, foci would be 7, -3 minus square root of 17, and 7, -3 plus square root of 17. And if this was something that could be simplified, I would do it, but it can't, so I just have to leave it like that. So if it was actually a whole number, then, or an integer, then I would add and subtract it just like I did there. All right, now finally, I've got the foci, I need the eccentricity. So I know my eccentricity E is c over a. I figured out what c is. It's square root of 17. I know what a is. Remember, a squared was 81, so a was 9. So it's the square root of 17 over 9. And so normally there we also want to give an approximate value so we can see just how eccentric this is. And this one is it's pretty close to half, a value of a half. So it's fairly eccentric. Remember, the eccentricity is going to be between 0. 0 is no eccentricity, it's a circle. But a very low value here, close to 0, means that it's very circular. This one is not very circular, but it's not also really stretched out either. Okay, with that, there's your homework. It's 22 through 40, the even ones. So work with the eccentricity as well as the equations here for ellipses. And we'll give you a chance. We'll have a Zoom session tomorrow if you have questions. All right, until tomorrow.